In this video, we'll be connecting the Pythagorean theorem to the distance formula and applying them to solve for area and perimeter in the coordinate plane. So some key things you need to know before we start. As review, the perimeter is the total distance around a polygon. So for the perimeter of a triangle, we add all three side lengths together, and the perimeter of a rectangle, we add all four side lengths together. And we've also seen the perimeter of a rectangle written as 2L plus 2W, and that makes sense because in our rectangle we have two sides of length L, two sides of our width W, and so adding those together gets us our perimeter. Area, as a reminder, is the amount of space within a boundary, or in this case, it is the size of our polygon. So the area of a triangle is this equation here. The area is 1/2 times the base times the height. So B stands for base of our triangle, H stands for height. And we can think of this in our right triangles as these are our two legs because they do have to be the sides that form a right angle. If we don't have a right triangle, we can create one, and if we knew the height or that length from this point to that tip at the top, then this whole distance would be our base, and then this distance here would be our height. The area of a rectangle is L times W, which stands for length times width. And so to find the area of any rectangle, we would just take this length, whatever that distance is, multiply it by the width, and we would get our area. Okay, so we'll start with our first example. What is the perimeter of triangle TUV? So perimeter, we need to find all three lengths of each side. And this one we can see is 3 units long. This side is 4 units. And then we don't know this one, and we can't count it, but we can calculate it using our Pythagorean theorem. So remember, that is a squared plus b squared equals c squared. So now we know this length here is 5. To find the perimeter, we just add up those three sides. So 3 plus 4 plus 5 equals 12 units. And for area of this triangle, we're going to use our equation. A equals 1/2 times the base times the height. And remember, we said base and height we can think of as the legs of our right triangles. So 3 and 4. So I'll just plug those in here. 1/2 times 3 times 4. And when we multiply those together, we get 6. And then area, our units are always squared. So we have 6 square units. Our second example says to find the area of square EFGH, and then we are given the vertices and their coordinates. So I'm going to just graph these points. E is at 5, -6. F is at 5, -9. G is at 8, -9. And H is at 8, -6. And now it's really easy for us to see these side lengths, it's a square, so all the lengths are the same, and they're each 3 units long. We would just need to do 3 times 3. Area is length times width, which is 9, so our answer would be 9 square units. Our third example, what is the area of triangle ABC? So if we look at this triangle, it's not a right triangle. And if we tried to make a line to form a right angle as our height, we don't really know the lengths of those either. So this one's a little more challenging. We do know how to find the area of a rectangle, and we know how to find the area of a right triangle. So we need to try to create those shapes somehow so that they're useful to helping us finding the area of this triangle. So what I'm going to do is create a triangle, a right triangle here, and we could calculate the area of this section, and then we could calculate the area of that right triangle. And why is that useful? Well, if we look, now we have formed a rectangle, and this entire green triangle is within that rectangle. And if we could find the area of the rectangle and then subtract this area, and this area, then that is going to give us the area of our triangle ABC. First thing we'll do, area of a rectangle. This distance here is 11 units long, and then this distance here looks like it is 20 units long. So for our area of the rectangle, we take the length times the width, 11 times 20, and that gives us 220. Now we need to calculate the area for each of these individual triangles that we created. So we'll start just with this first one. We know this length is 11, and this side length here looks like that is also 11. We have 1/2 times 11 times 11, we get 60.5. Okay, so there's our area there. Now we're going to move on to this triangle. Again, we have this full area of the rectangle here, and then we need to subtract this section, and this section, and when we do that, we're going to be left with just the area of this triangle in the middle. So 220 minus our first triangle was 60.5, our second triangle was 22.5, our third triangle 60. 77 square units. That's our area of triangle ABC. Okay, so what is the distance formula and how is it connected to the Pythagorean theorem? If we go back to problem 1 for this, we found the perimeter of triangle TUV without even knowing the distance formula. So why does it matter? Well, the distance formula is derived from the Pythagorean theorem, but it just takes us directly to the step that we need to find that length rather than us drawing out this triangle, finding this distance, and then eventually calculating this distance. So it gives us the direct formula to get there, and especially as our triangles get bigger or distances between points get bigger, this distance formula is just going to be more efficient for us to use. So when we found the distance that was missing here, we found out this was 3 units long because we can see that, but we could also find that by just taking our y value up here, subtracting the y value down here, and it would find that the difference between those y values is 3. In our x, again, we counted this, and we could see that it was 4 units long, but we could take our x value here and subtract our x value here, and it would give us the same thing. The difference between those two x coordinates is 4. So V is at the point 0, 2, and U is at the point -4, -1. If we use our distance formula, we need to decide x1 and x2, and you can see how these are labeled. x1 and y1 have to be the coordinates that go together for the same point. So I'm just going to make this x1 and y1, and it doesn't matter which one's x1 and which one's x2, but the x and y have to go together. So we'll make this x2 and y2. And then I'm going to write out our distance formula. It is x2 minus x1. So for us, that's going to be -4 minus 0 squared plus y2 minus y1 squared, so we need -1 minus 2 squared. And then we can simplify what's in those parentheses. So -4 minus 0 just gives us -4 squared plus -3 squared, and then this gives us -4 squared. Make sure if you type that into a calculator, you're using parentheses. 16 plus -3 squared is 9. This gives us the square root of 25, which is 5. And if we remember, that's the same answer that we got when we did this example problem the first time. So it doesn't matter if you think of it as finding this distance using the Pythagorean theorem or using the distance formula. But again, if you don't have a graph or if your distance between points is really large, this distance formula might be more efficient for you to use. We'll do one more example using the distance formula between the points -3, -2, and -1, 8. So on this one, we're not going to graph it, we're just going to go straight to the distance formula. So we'll label this as x1, y1, and we'll make this one x2, y2, and then we're just going to plug those in to our distance formula here. We end up with the square root of 104. Now if you type that into your calculator, it's going to give you a decimal, but the second part of our problem says to write your answer as a whole number, and obviously we won't get a whole number with this one, or a fully simplified radical expression. So to simplify this, there's two things you can do, or two ways you can think about it. You can take this 104 and we're going to split it up into all of the prime numbers that multiply together to get us 104, and that's called prime factorization. So we can divide this up and make it 2 times 52. And then we could split that up again and make it 2 times 26. And then we can split that again and make it 2 times 13. And 13 is a prime number, so we're going to stop there. 2 times 2 times 2 times 13 gets us 104. So if we wanted to simplify, instead of the square root of 104, that is the same thing as the square root of 2 times 2 times 2 times 13. And we have these 2 times 2, which makes it the square root of 2 squared, or 4. And anytime we have that, it just becomes 2. Okay, so those are taken care of. 2, and then we have 2 and 13 left. So the square root of 2 times 13. And we can't really do anything to simplify that at all. So our final answer is just going to be 2 times the square root of 26. Another way that you could think about it, if you look at 104, once you get to that point, you could just say what perfect squares go into 104. And our perfect squares are our numbers like 1, 4, 9, 16, 25, and so on. And if we have 1, that's not really going to simplify anything for us. But if we move on to 4, does 4 go into 104? And it does. So we can take the square root of 104 and split that up into the square root of 4, because we know that's a perfect square, times the square root of, and if we take 104 divided by 4, that gets us 26. And then we know the square root of 4 is 2. The square root of 26, we can't simplify at all. So that's just another way that we could get our correct answer of 2 square root 26.